Fun, here we go. Fun with the sum to product rule. So we just got to find which one we want here. And so I had looked up this Clark University page, and I have a sum that I want to change the product. And so mine is back here, a difference in signs. So the difference in signs right here says it should be twice cosine alpha plus beta over 2 sine of alpha minus beta. Okay, so 2 cosine sine plus minus. Let's write that down. So the formula we're applying is the sine of alpha minus the sine of beta equals twice. Do I have the order right? It was sine and then cosine, right? No, cosine then sine. Cosine of the average times the sine of half the difference. All right, so my alpha is the 7.5z and my beta is the 6.7z. So we're going to get twice cosine of 7.5z plus 6.7z over 2 sine of the difference over 2, 7.5z minus 6.7z over 2. Okay, so adding those, what do we get? We get 7 and 6 is 13, 5 tenths and 7 tenths is 1.2, so 14.2. Calculator would be a good idea to double check. Over 2 is going to give me 7.1 z. So I have twice the cosine of 7.1 z, and then the difference. Okay, 6.7 to 7.5 is 0.3 plus 0.5, which is 0.8 over 2. And again, we should double check that on a calculator. It's good to do in your head though, which is 0.4. So sine 0.4 z. How would I check this? Well, a couple things. I would double check that I did that arithmetic right on a calculator, and then I would see, does the graph of this sucker match the graph of that sucker right there? So let's try it. So let's see, 7.5, 6.7. So we have the sine of 7.5x minus the sine of 6.7x. Whoa, that is a cool wave. Let's zoom out on that sucker. Ooh, look at that. It's a wave within a wave. Sweet. All right. And we said that could be rewritten as twice the cosine of 7.1x, which is that rapidly oscillating one. Oh, that's interesting. Check it out. They have the same zeros. Look at that. Okay. Times the sine of, was it 0.4, I believe, x. Yeah, it sits right on top there. Well, that, check this out. All right, so if we get rid of that sine, then this thing has a constant amplitude, but it has a similar period, right? The zeros are the same. If we get rid of this cosine, check this out, then I get a bigger wave that contains that smaller wave. And it turns out this is a pattern called amplitude modulation. AM radio works this way. It's one wave that's kind of contained within a different wave. We'll look at more of that later in the course. Sweet. That's so beautiful. Isn't that beautiful? I think that's beautiful.